Let's turn our attention next to exercise 8, where we will be comparing the payment and future value functions in Excel to calculate the financial impact of a decision. Now, in the private sector, this formula would be used for calculating interest rates and loans. In the public sector, leaders can use these same formulas to determine the impact of financial decisions over a number of years. So while the Air Force might not be taking out a loan for capital equipment, they are purchasing equipment over a number of years, or labor over a number of years, or supplies over a number of years. And calculating those costs over time is an important management function. So to begin, note that you've saved the exercise as exercise 8 complete to preserve the original structure of the exercise. And then we're going to review the inputs. These are the variables that you take to the exercise. For example, we're going to undertake an initiative with a current cost of $180,000. We expect the cost of that initiative to grow at 5.25% per year over a course of 5 years. And importantly, we will be calculating that by month, so we'll need the periods per year, in this case, 12 months. So, to make these calculations, let's first copy these cells into the value column and go over them one by one. So first, the monthly planning factor is simply the annual planning factor divided by 12. And so the annual planning factor is 5.25%. Divide that number by 12 and convert it to a decimal, and we get 004375. The number of periods is the planning period in years times the number of periods. So 5 years with 12 months each converts to 60 periods. The monthly budget requirement is the amount we will pay every month for this $180,000 initiative over the course of 5 years. So it takes the monthly planning factor times the number of periods times the total initiative cost, and we get a monthly cost of $3,417.48. So the total planned funding takes the estimated budget requirement and adds it to the total initiative cost. And so over the course of 5 years, this initiative will cost us $205,000. That accounts for monthly growth. So the overage from that $180,000 present value is $25,000. Add that to the original 180 and you get $205,000. That is the cost growth over time. So again, this function allows us to visualize the growth of cost over time. Let's next turn our attention to the future value worksheet. This function allows us to determine the savings over time for an initiative. So if we take a manpower initiative to reduce rework, we have a number of assumptions that go into that. That is, we expect this initiative to produce a cost avoidance of $3,500. That annual cost assumption projected over time will grow at 4%. And this is a 4-year initiative, obviously with 12 months. So similar to the payment function, we'll copy those functions into the value column and address them one at a time. So again, the monthly factor is simply taking that annual factor and dividing it by 12. In this case, that 4% factor divided by 12 is 0.0033 and on. The number of periods is 48. Again, 4 years with 12 months each. The cumulative value, and this is where the real work will get done, is taking the monthly escalation factor times the number of periods times the cost avoidance And then those zeros represent the inputs. So at the beginning, there are $0 in this account or $0 saved, so that number is 0. And the second 0 represents the input timing. The inputs will occur at the beginning of each month. If they were to occur at the end, that number would be a 1. But as you can see, the total cost avoidance is $181,000, $858.60. And the straight cumulative cost avoidance, let's convert that to a dollar figure, is $168,000. And the escalation effect is $13,000. That is, we save $168,000 and project it over time. That adds up with $13,000 for a total of $181,000 of cumulative cost avoidance. So that is the payment and future value functions of Excel. Now it's your turn. Exercise 8, have a go.